Alright, we are looking at some items that my students had trouble with, and one of the items they said they had trouble with, a few of them did, was number 13. Now, 13 is a challenge item, so it's understandable some of them would struggle with this item. Let's go ahead and make it just a little bit, let it fit on the screen a little bit better. Okay, so this challenge item says, how many toothpicks do you need to make the nth figure in the sequence? Now that n, that's a variable that stands for any. Like here we have first, second, third. They might be interested in wanting to know how many toothpicks does it take to make the 50th. You know, I mean, it'd be pretty easy to figure out how many it takes for the 4th, because when you look at this, I see it takes 4 to make 1. And then it takes 7, 1, 2, 3, 4, 5, 6, 7 to make 2. And it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to make 3. And so it would probably take 13 to make 4. I mean, that would be easy. You're just, it looks to me like I can tell right off the bat they're adding 3 every time. You got that? But if you have to do the 50th one, how in the world are you going to be able to figure out very quickly how many toothpicks it would take unless you have an algebraic expression that helps you? It's going to take an algebraic expression so that you can do this quickly. Now, we got to figure out, math practice number 7, what is the pattern and structure of these figures with toothpicks so that we can figure out an algebraic expression that will help us determine how many toothpicks in any given sequence. Alright, so we got a visitor. Let's see what she needs.
And so specific in here. She wanted me to ask you if she's having for snack.
Tell her I've got little mini Snicker bars and little mini Kit Kat bars.
Okay.
Alright, let's go ahead and work on this sequence for number 13. Now, what we could do, let's look at the first one. The first one, for first, it has 4 toothpicks. 4, I'm going to put TP for toothpicks. And the second one, it's going to take, like I said, 7 toothpicks to make it. And the third one, it's going to take 10 toothpicks to make it. So let's see if I can get some help from my class to see if they notice something about the pattern here. Alright, what do you notice about the pattern? I'm going to sling this one at little Merle. What do you notice, Merle?
It's going up by 3.
It goes up by 3 every time? Okay, well, that's good. So the 4th one would have 13, the 5th one probably have 16, and so on, right? Okay, I don't want to have to stand here and keep adding 3 every time until I get to the 50th one. You understand? I want a quick algebraic expression. So how can we use that knowledge that it goes up 3 every time? How can we use that? All right, what do you think, Will Burns?
You could add all of them up and then do n times whatever the sum of them is.
What do you mean add them all up?
Like you would add 4 plus 7 would be 11, and 11 plus 10 would be 21, and then you would do n times 21.
Okay, so I had a hard time hearing what you said. So you're saying, one more time, because I had a hard time hearing it.
Okay, you do 4 plus 7 is 11, plus 10 is 21, and then you do n times 21 to get whatever number.
Alright, so if I want to know the second one, I would say 2 times 21. That would give me 42. And I can see right off it took only 7 toothpicks to make the second one. It didn't take 42. So I'm not going to multiply. I'm not going to multiply it by 21. No. All right. What do you think, Andrea?
Since it went up by 3, you can multiply 3 times n.
All right. So you say multiply 3 and n. Okay. Well, let's see how that would do. Let me get a little bit of scratch paper here, and we'll see how that would do. So it goes up 3 every time. So she says we could just simply multiply 3. So if I have 3n, do you care if I call it 3n? I'd rather call it 3n because we have a coefficient variable and it makes it very quick. So let's see how it goes. Let's test it with number 1. 3 times 1 equals 3. That's 4 toothpicks. Let's try this one. 3 times 2 gives us 6 toothpicks, but there it's got 7. 3 times 3 gives us 9, but there it tells us 10 toothpicks. Now I'm seeing a pattern that kind of, I can see how to get there. Colby, what do you think?
In the first one it has 4 because it has to make a perfect square. Well, at the end, after you multiply it by 3, you need to add 1 more toothpick.
Well, let's see if that happens. So 3n plus 1. So 3 times 1 is 3, plus 1 equals 4. Okay, let's try with this one. 3 times 2 is 6, then 6 plus 1 is 7. Hey, I think we may have cracked it. 3 times 3 is 9, 9 plus 1 is 10. Hey, it looks like you cracked it, Colby. Good job. So we had some help from Andrew, who said 3 times n, and we had some help from Colby, that said plus 1. Let's do a test. Let's say that we have 3n plus 1, but let's come up with, we want to know the 50th. How many toothpicks for the 50th? So we could say 3 times 50 equals 150, plus 1 equals 151 toothpicks. I think, Colby, that's great. I think Andrea and you, this is a good example of how the more people that are working together, the better we are. The better we are. So that's great. It took teamwork and we got this one done. So how many toothpicks do you need to make the nth figure in the sequence? Our algebraic expression is going to be this right here, 3n plus 1. 3n plus 1. Did anybody have that already? Johnny had it? Okay. Alright, and Ethan had it. Alright, so some had it already. How many of you were at least close to it? How many of you had at least the 3n part? Nobody? Okay. Alright, how many of you feel like you understand it better now? Okay, okay.